halfway through how to solve various quadratics. We've done it with isolation and we've done it with factoring. Now we're going to use what's called completing the square. Okay, completing the square is going to look a lot like isolation whenever we actually solve it. Okay, but it's one of those things, it's one of those whenever you get a problem that you can use completing the square, you're not going to be able to factor it. Okay, you could use quadratic formula, which we'll talk about tomorrow. Okay, but we'll get into that tomorrow. So, but whenever you use completing the square, there is a time and a place when you want to use it. You can always use it, but there is a time whenever it's going to be easier than others. Okay? And there's going to be a time whenever it's going to be a lot harder to do than other problems. Okay? And hopefully as we go through it, you'll figure that out, what you need to happen kind of on your own. So what you're going to do is you're going to start with, okay, you know that a perfect square trinomial is whenever you have something times itself, so a plus b squared or a minus b squared or whatever you have, okay, is a perfect square trinomial. We can shortcut it by squaring the first term, so that's how we got the a squared, and then multiplying the two parts inside and doubling it, and then squaring the last term. So whenever we complete the square, what we're going to do is we're going to turn this into basically an isolation problem. Okay, whenever we get into graphing, after next week, we will call this vertex form. Okay, it's just another form as far as to be able to graph it. Okay, to be perfectly honest with you, whenever we graphing in vertex form is going to be the easiest out of any way. Okay, so you being able to put it in vertex form by completing the square is going to be very beneficial to you later on. Okay, because a lot of what we do will be in vertex form. So first off, kind of the basic part of it is writing the expression as a square of a binomial. So whenever you have a square of a binomial, what you have to have is a perfect square in the front, a perfect square in the back, and then whatever your square root of your back term is, needs to be the number that you can double to get the middle term. Or, if you look at the middle term, what's 16 divided by 2? 8. What's 8 squared? Okay. So if it's a perfect square, what has to happen is you have to be able to divide that middle term by 2. And you have to be able to multiply that term, whatever it is, divided by 2. So 16 divided by 2 needs to be the same thing as 8 squared, or needs to be the same thing as that number squared. So if I can basically take, an easy way to check to see if it's a perfect square is if I can take 16 and I can divide it by 2 and square it, if it's the same thing as my back number, then it's going to be a perfect square. Okay? Is 16 divided by 2 and then squaring it 64? Yeah, because 8 squared is 64. So an easy way to write this, what is 16 divided by 2? 8. So we're going to go x plus 8, quantity squared. If it's a perfect square, all you have to do is take that middle term and be able to divide it by 2, and you're just going to slide it right into that parenthesis. Okay, an easy way to check is you can multiply everything out and go x plus 8 times x plus 8. The easy thing to do, though, is to take that middle term, divide it by 2, and square it to get that back value. So like on 2 and 3, I have negative 4. So C is equal to B over 2 quantity squared. Okay? A is the number in front, B is the middle term, and then obviously C is right here. So what's B on number 2? Negative 4. So I'm going to have negative 4 divided by 2 quantity squared. What's negative 4 divided by 2? Negative 2. What is negative 2 squared? 4. So if we're going to write this, so the first thing it says to do two things. First thing it says find the value of c that makes the expression a perfect square trinomial. Boom, we did that right here with 4. Then it says write the square of a binomial. So you can do one of two things. We could rewrite this as x squared minus 4x plus 4. Okay. Anytime it asks for a perfect square, trinomial, that's what it's going to look like. Okay, if it asks for a perfect square trinomial, you're just basically going to put the c, or put the value that you got for c in there. Now, if we're going to write it as a square of a binomial, all you have to do is, one, not overcomplicate this, and take whatever your number is right here. What's negative 4 divided by 2? Negative 2, right? You're just going to put it in a parenthesis and go x minus 2. Okay? That number, whatever you want to call it, okay, is going to go right there. Now, one thing I do not want to see, okay, and I know I will, is I do not want to see this. I do not want to see x minus 4 over 2 squared. Do not do that. Don't be lazy. Just divide negative 4 by 2. Okay? Don't write it as negative minus 4 over 2. So anytime you have a perfect square, I can take that middle term, divide it by 2, and it will give me the binomial squared. Now, on 3, what do we need to do here, though? How are we going to find c? What do we need to divide? By what? 11 by 2. So 11 divided by 2, and then quantity squared. What's 11 squared? 121. What's 2 squared? 4. So if we're going to write the perfect square by trinomial, or if I would basically just plug it in right here, I would have x squared plus 11x plus 121 over 4. So there's the trinomial. Okay, if it asks for a trinomial, there's the trinomial. Which value do I need, though, if I want the... Bless you. The binomial square. What value do I need to take? I'm going to have a parenthesis. I'm going to have it squared. I'm going to have x. What's going to go right here? It's going to go in that blank. Plus 11 over 2. There's my square of a binomial. All I did was take this value and plugged it in right there. So whatever b is, anytime you want to write a binomial square, you can always square or define that value. I'm just going to take this number, divide it by 2, slide it right in there. Questions there. So now when we actually solve it, okay, We're not going to worry about putting it in vertex form until we start to graph it. So we don't have to worry about it. So just take that out of your mind. First thing I want to do though, anytime I solve this, okay, the first thing I have to do is to move whatever my C value is, if I have one. Okay, if I have a value over here to the end, I'm going to take it and I'm going to move it over to the other side. So in doing that, I'm going to have x squared plus 6x. Now, here's what I want you to do. You're going to go plus, write yourself a blank, like this, put an equal sign. The 8 is now on the left, or on the right side. Put another plus sign and another blank. Now, any time that we complete the square, whatever I put in this blank right here on the left, I need to put the same thing in the blank to the right. So I need to fill in that blank. All I'm going to do, okay, do not, overcomplicate this. I'm going to take whatever this value is right here. I'm going to divide it by 2 and square it. So, positive 6 divided by 2 and square it. What? I'm going to omit this step right here. You'll have some people that'll do that. That's fine. That's completely up to them. And if you want to do that, that's fine. But what I'm going to do is I'm going to go ahead and turn this into a binomial and turn it into a binomial squared. It's going to be x, and then all I'm going to do is slide that number right there. What is 6 divided by 2? Positive 3. Now, I still have everything over on the right side that I need to take care of. So, I have 8. And you can do the step here in gray if you want. But realistically, we're not even going to use the step in gray because we're just going to take the 6 divided by 2 and we're going to put it right there. Okay? The only reason really we need this is just so we can take 8 plus 9 and get 17. Now, where did I get the 9? 6 divided by 2 is 3. 3 squared gave me 9. What's 8 plus 9? Well, it's 17. Now, we can put this in vertex form, but it's not really going to do you any good because we're just going to move the 17 back over, so we'll get to that later. Have you ever in your life, or at least the last week, solved anything that looks like that? Really? Crazy. Well, you need to do your homework then. So if I have x plus 3 squared equal to 17, how do I get rid of the squared? Square root. Okay? Everything from the green on is going to be the same. It's just going to get you a different value. You're going to do everything the same way. You're going to take the square root of both sides. And I'm going to get... So I'm going to take the square root of both sides. I'm going to have x plus 3 equals plus or minus the square root of 17. Now what do I need to do? Subtract 3. X is equal to negative 3 plus or minus the square root of 17. And I am finished. Now, in some cases, you may look at it and you may say, okay, I don't need to do this in completing the square, or I can factor this. That's okay. If you think you can factor it, factor it. Okay? Now, one thing I will tell you, okay, as you go, so if we look at, let's look at 3. Let's skip 2 and let's go to 3. what can I do here with everything? I can factor out a 5, right? Okay. Now, here's what I would suggest first is anytime you can factor, I would still move the 30 over to the other side and have 5x squared minus 10x, leaving your blank, and then negative 30 and having your blank again. If you have two numbers, okay, I'll be the first to tell you that whenever you have a number in front of your x squared, you want to make sure that we can factor out with the first two parts. It's not so bad if you don't have, like down here on 4, it's not so bad that you have to factor it out of the back part. That's why I send it over to the other side. Okay, so if I do that, I'm going to have 5 times x squared minus 2x plus, still have the blank, nothing changes there, negative 30 plus, I still want to have 5 times whatever's in the blank. Now, why do I have 5 right there? What did I do here? Right, well, I brought 30 over. But why do I have a 5 in the blank on the right side?
Because you didn't take it out.
Right. I did the same thing over here, right?
Why did you get rid of the
Say that again.
Why didn't you
Since I factored the 5 out of the red on the right side, I need to factor out whatever's going to go in that parenthesis on the left side. I need to do the same thing on the right. Because that 5 would get multiplied here with the negative 2 over 2 squared. So it's going to get multiplied by the negative 2 over 2 squared on the right side. Now, this is why I do not rewrite. This is why I just skip straight down. I still have the 5 outside. That just dropped down. What's going to be in my binomial squared? X minus 1. Now, how did I get the minus 1? What's negative 2 divided by 2? Negative 1. I'm doing the same thing every time. I'm taking whatever that middle term is, and I'm going to divide it by 2. So, I need to set the right side. I have negative 30. What's negative 2 divided by 2? Negative 1. What's negative 1 squared? 1. What's 5 times 1? 5. So it's adding 5. So what's negative 30 plus 5? Negative 25. So now, and I'm going to give myself a little bit more room over here to the right. I have 5 times x minus 1, quantity squared, equals negative 25. How do I isolate, or how do I get the x by itself? Divide by 5. So I have x minus 1 squared equals negative 5. Now what? Square root. Now I take the square root of a negative, so I have x minus 1 on the left. What's the square root of negative 5 going to turn into? Plus or minus. What do I need to do if it's negative? I times the square root of 5. Okay, all I did was just take that negative, move it outside. That's why it became an I. Last thing I need to do, add the 1. So x is equal to 1 plus or minus I times the square root of 5. Yep.
Why do we get a negative 1 for the...
Look at number 5. What's the problem with 5? Can't factor anything out, right? Okay? If you can't factor anything out, don't do completing the square. Alright? So if you can't, like do you understand on 4 that I can move the 16 over and I can have 3x squared minus 12x plus something equals negative 16, and then I can still factor something out of these two parts, right?
Yes.
I can't do that here. Okay? I can do it on 4, and I can treat 4 the same way I did on 3. But I can't do that on 5. So I don't even want to think about doing completing the square. So if you see anything like that, as far as your assignment, don't do completing the square. I would see if you can factor it first. If you can't, then when we show you quadratic formula tomorrow, that's what you're going to want to do. Okay, so if you see anything like this, where you have A2 or whatever that you can't factor, just put cannot complete the square. Okay? Because that's going to be a lot more than you want to get into. And there's no reason to try to do a problem that's just going to be a complete and utter mess.
Did you do number 2 then?
So, same way on 4. We want to move the 16 over. So I have 3x squared minus 12x plus my blank equal to negative 16 plus whatever my blank is. So if I factor out the 3, since it's factorable, I can factor out a 3, and I have x squared minus 4x plus whatever's in my blank equal to the negative 16 plus, now don't forget the 3 times whatever ends up in that blank squared. So whatever ends up in that blank, I need to square it. So I'm going to take the negative 4 right here, divided by 2, and square it. So I'm going to take the same thing and have negative 4 divided by 2 there. So the left side will be 3 times x. Negative 4 divided by 2 is negative 2, so minus 2 quantity squared equals negative 16. So negative 2 squared is the same thing as 3 times 4. So negative 16 plus 12 is negative 4. So I'm going to come up here, give myself a little bit more room. There we go. So 3 times x minus 2 quantity squared equals a negative 4. So I'm going to divide by 3. So I have x minus 2 quantity squared equals negative 4 over 3. So now I need to take the square root of both sides. Now if I do this, I'm going to take the square root of the top and the bottom. So I have x minus 2 on the left side. Now what I would suggest is simplifying this right side first. So I have 2i over the square root of 3. I can't have a radical in the denominator, so I'm going to multiply by the square root of 3 over the square root of 3. And the left side is just going to be, or the right side is going to be plus or minus 2i times the square root of 3 over 3. Now just add the 2 to the other side. So x is equal to 2 plus or minus 2i times the square root of 3 all over 3. You can still end up with i's, that's okay.